Hi, this video will cover the muscle segmentation module in Mimics, which is new since version 20 of the Mimics Innovation Suite. My name is Sjoerd Kolk and I'm a business developer for the orthopedic and CMF market segments for the Mimics Innovation Suite. Now the muscle segmentation module, it allows you to semi-automatically segment many muscles in one go, rather than segmenting them all one by one. And this can yield a large reduction in segmentation time when dealing with large groups of muscles. The tool is particularly suited for dealing with MRI images on which muscle boundaries are well visible, such as in the example shown here on the left side. Now, two inputs are needed to run muscle segmentation. A number of previously created atlases, with each atlas being stored as a separate Mimics project, and one or more input masks that you need to create for the current scan that you want to segment. Then what the algorithm will do is it will first register the atlases to the current scan. Then it will determine the best matching atlases for that particular scan. And finally, it creates the individual muscle masks by using a voting mechanism on the basis of the best matching atlases. And I will go into a little bit more detail as we go on later. So the topics that I'd like to cover in this video is how to create that input mask, and two, how to run the muscle segmentation tool. So that hopefully you'll be able to also create results that look like that. So, creating the input mask, which is the first step that we're going to cover. Here I have a Mimics project that I'd like to segment. So this will serve as the basis for my input scan. So as you can see, it's an MRI scan where all of the stacks have been stitched together already. So this is assumed to be the starting point. Here I've already included a mask so that you can see what the end goal is that we're going to strive for in this first step of the video. So we're going to aim to create a mask that encompasses all muscle tissue while still maintaining some of the boundaries between those muscles, because that will help the algorithm. As you can see, all of the muscle tissue is included, none of the bones are included, nor the fat, etc. So that's the end goal that we're going to work towards. So let's see how we're going to get towards that goal. If we go here to the muscle segmentation menu, you will see that there is several menu items here. Now, most of these tools will look quite familiar to you probably if you've worked with the Mimics Innovation Suite before, such as new mask, region growing, split mask, and edit masks. These are actually the two new tools that are included in the muscle segmentation module. The first one is gradient threshold, and the other one is the muscle segmentation tool itself. So what we'll do first is we'll generate a new mask. Now this new mask, it should contain the muscle tissue and as less as possible of all the other surrounding tissues. So what we're going to do is we'll play around a little bit with these values such that we get a threshold that includes almost all of the muscle tissue and as few other tissues as possible. Now, as you can see, since this is an MRI scan, there's sometimes some inhomogeneities in the field strength. So you may get some areas of muscles that are more dark than others, and you may get some areas that are actually fat that are more dark than some of the muscle tissue. So we'll need to play around with these bounds until we include all of the muscle tissue. So we don't want to go too low, because then there would be large chunks of muscle that would be missing. Alright, this is looking pretty good already. Maybe there's a slight bit missing over here, so we'll just increase it just a little bit. And also what's quite convenient in Mimics 20 is that you can immediately crop your threshold with this cropping box. So you don't have to do that afterwards. So in this case we'll crop it to the knee, because for this demonstration I'm just going to focus on one area, which is the thigh and the hip area over here. So after clicking OK, we have our first initial threshold. Now the second step of the tool, if we go here, is called gradient threshold. Now what gradient threshold will do is it will look for strong gradients in the image, such as transitions from muscle to fat or from fat to air, for example, and it will remove those strong gradients from the image. So it would remove this edge here, for example. So in this tool you need to select your mask that you want to work with, and you need to select this value here, this gradient threshold value. Now in this case there's not a slider with it that we can play around with, so in order to find this value that we want to fill out here, there's actually a little trick that we're going to use now. So if we hit cancel, we switch off the mask, we go to image, apply a filter, and we select here a gradient magnitude. If it's not there yet, you just click here, click on gradient magnitude, and then you can already see what is going to happen. If we click OK, that filter is added to the list, and now here in the image menu we'll choose show filtered images. As you can see, this highlights all of the boundaries in the image. So the boundaries between fat and air are particularly pronounced, but also some of the boundaries between muscles are also included here. So what we will do is we will apply a threshold on this image. And by playing around with the lower bound of threshold, we need to make sure that we select as many muscle boundaries as possible within this image. So as you can see, if I move it higher, then fewer of the boundaries are included. If I move it lower, then more is included. And generally speaking, it's okay if it looks a little bit sloppy, let's say, on the inside here especially. So it's okay if it looks a little bit sloppy within that muscle compartment, because all of these muscle boundaries that are hardly visible, such as the ones here between the vesti, for example, it's better if they are selected here. So in this case I'd say somewhere around maybe 30 to 45, let's make it 40 to go somewhere in the middle. That looks to be pretty reasonable throughout the image. So in this case we're not going to click OK here, because we don't need to apply this threshold on here. We just need to remember this value because we're going to use it for the gradient threshold. So going back to the unfiltered images, we'll do segment, muscular, gradient threshold, and here we'll fill in that value. What I always like to do is add underscore and then the value, such that if you are experimenting with some of these different gradient threshold values, you can still find back which mask was generated with which threshold. Okay, so if we just turn that one off for now, you can see what the gradient threshold did. It did a pretty big cleanup of this mask. So as you can see, the bone tissue has been removed, the fat tissue has been removed, or at least the boundary over here. There is still some fat here selected, and we'll move that in the next step. But all in all, it's already a pretty good mask, I'd say. Over here you can see that some of the bladder, for example, has also been segmented. So we want to remove that, and that's what we'll do in the next step. So we go here to muscular and then split masks, and this is actually the same as over here. So you can use it in either menu, it's the same tool. Now if you're unfamiliar with split mask, it's a feature that we added in Mimix 19. and it allows you to split one mask into two really easily. So for example, if I want to remove this bladder here, I can just select that part of the image that I want to keep, which contains the muscle tissue, and I select that part of the image that contains the bladder. And often it is enough to segment it or to select it in just a couple of slices. They don't need to be selected in the same slice either. It can just be, you're quite free with this tool, let's say. So I don't want this. I do want that. And maybe one more, just in case. And now I'm holding Control and the left mouse button to make that cursor a little bit smaller. Then just click OK. And if all went well, this mask has now been split into two, so cyan and a fuchsia part. So the cyan is what we want in this case. And we can see that that worked quite well. Yeah, that seemed to have worked very well. So with just a couple of clicks, we separated those two into two, or that mask into two masks. So this mask is looking very good as an input to muscle segmentation. As you can see, some of these boundaries between muscles are left open, which is great because that will allow the algorithm to segment the muscles better. Now what I need to do is I need to rename that mask into something that will be recognized by the algorithm. So in this case, I'm going to name it upper right. So now that we have this input mask, we're going to go back to the presentation for a second because we're ready for step 2, which is running the muscle segmentation tool. So we once again click on segment, muscular, and then muscle segmentation over here. Now there's quite a few options in this tool, so we're just going to take it slow and start from the top. The first thing you need to do is load your atlas collection. So you go to wherever you've stored your atlases. In my case, it's over here, so I'm selecting this folder. Now the next step is to select the masks that you want to use in the segmentation. In this case, I've only segmented the upper right segment. I could have also done the upper left, lower left and lower right as well. So once I've selected that, I'm going to click on Check Project Compatibility. And in this way, the tool will check if the mask here, upper right, is also present in each of these atlases in this folder. In this folder there are 10 atlases. I will show them. And all of these 10 atlases each contains that mask called upper_right. And that matching mask will be used in the registration process. Now let's go into the parameters of the actual tool. So the first one is called grid size of transformation. Now when the muscle segmentation algorithm runs, the atlases are registered to the current scan segment by segment, like lower leg, upper leg, etc. So the grid size of transformation parameter determines how accurately this is done. Now if a larger value is set, the transformation will use fewer points as an input, and as a result the calculation time will be reduced. Now a smaller grid size provides a more flexible and accurate transformation. I do want to note here that the grid size has quite a significant influence on the processing time of the algorithm, so I would advise to just start with the default values, which basically goes for all of these parameters, and then play around with the settings until you get to the optimal setting for your particular data sets. So the second option is called sample percentage. And this parameter allows you to set the percentage of voxel samples that will be used to measure the correspondence between each segment and the corresponding atlas segment. If you increase the value, more voxels will be used in this process, leading to a more accurate registration. Now this parameter has a considerable effect on the processing time. Therefore, caution is advised when increasing this parameter above its default value, which is, I believe it's 1%. Now setting the parameter above 50% and even above of 20% or so is hardly ever needed. So I would suggest this experimenting with it between like 1 and 10% or something like that. So this next parameter here is actually not a parameter that you can set, this available atlases. This is simply a number that's provided for your information so that you can verify if all of the atlases in your atlas folder have been correctly found by the muscle segmentation tool. Now this next one, the number of best matching atlases to be used, is a parameter that allows you to limit the maximum number of matching atlases that are used during the segmentation. Now the number of atlases that is set here does not have any influence on the calculation time, but it is very important to choose it wisely. Now the reason for wanting to limit this number, rather than choosing the maximum number of atlases, is that in most situations there will be atlases that are very similar to the current scan. And there also will be atlases that are not as similar as to the current scan as some of the others, in spite of the registration process that takes place, which includes also scaling and non-rigid deformation. Now, for example, if there are 10 atlases available, using only the best matching, say 3 to 6 atlases or something like that, will likely lead to better segmentation results than using all 10 atlases. So for example, I can set it to 5 in this case. Now a little top tip here is that the correspondence values of the registration per segment of each atlas are shown in the log panel while the algorithm is running. So in this way you can observe if one or more of the atlases are consistently performing very good or performing very poorly, for example. Now this next parameter is called the atlas filtering threshold. And here you can set a minimum threshold for the correspondence value between an atlas and the current scan. Atlases that have a lower correspondence will then automatically be set to not be used. And this can particularly be useful if you're working with larger datasets, so with larger atlas collections. And this value allows you to automatically throw those out that have a poor correspondence, so something like 0.4, 0.5 maybe. Because from experience, most atlases will have a correspondence somewhere between 0.5 and 0.85 or something like that. This parameter is called the minimum number of agreeing atlases. Now the muscle segmentation tool contains a voting mechanism between the atlases with the highest correspondence that determines whether to assign a certain voxel to a certain muscle. And this parameter allows you to set how many atlases have to agree before that assignment is made. Now in most cases, setting this parameter to about maybe a third to half of the total number of atlases works best. Now if there are only very few atlases available, the value can be set to 1 or to the total number of atlases. In this case, since we have 10 atlases, we use something like between 3 to 6 best matching atlases, and the number of atlases that has to agree, we can set it to anywhere between something like 2 to 5 if we want. So maybe 3 could be a good number. Now this last option here will be the name that is given to the Mimics project that results from the muscle segmentation run. So if I want, I can name this, for example, auto segmented, and then what I always like to do is give it the values that I've used in that run of the tool. So 40, 10, 10, 5, 0.5 and 3, just for reference so that I can always remember what settings I used when running the tool. Now to give you an idea, if I click OK now, the tool is going to run for quite some time. It could take anywhere between 15 minutes to a couple of hours to segment all of these muscles. So I'm not going to actually show it right now, and I'm just going to click close here. Now just going back to the presentation, this is actually the end of the demonstration. If you would like more information, please feel free to contact us through your local account manager or application engineer, or write us an email through mimics@materialise.be. What you can also do is visit our website at materialise.com/MIS20, where you can learn all about the new release. Thank you very much. Bye bye.